A Florida State University program in interdisciplinary computing production.
And what I'd like you to do is learn a little bit about how the web works. And I use one of the most popular sites online for learning about stuff, literally stuff, how stuff works. And this talks, there's about 7 pages here. And by the way, this how stuff works isn't great because they have tons of ads, and it's often difficult to, it's really easy to accidentally hit an ad page instead of like the link to the next page. So somewhere down here, right here, in amongst all the ads is a link that says next page to move forward through this stuff. But essentially this talks about how the internet works and how what we call client-server software works. And so the internet is generally a client-server network, which means there are servers out there like iSpace that are turned on 24/7 and running software and just listening for people to call, and it will deliver what you want. It serves up the information you want. So we have a web server. There's email servers, there's chat servers, there's FTP servers, and it's not the machine, it's not the box that's the server, it's the software that runs on that box. And typically, you buy a fairly heavy-duty computer that can handle hundreds or thousands or tens of thousands of people using it and requesting it once, So generally, they're expensive computers with multiple processors, tons of memory and storage, and connected to the web. Or the internet to provide a service. Now what you need is software on people's computers that know how to request those services. And so what Internet Explorer and Firefox, Chrome, Opera, all of these are actually called web clients. So you have this web client software that knows how to make requests of a web server. It's like email software is email client software. I don't want to get into this too much, but there are some points of this that are important for understanding how the web works. And so you can read through this. I don't want to go through the entire article on how internet infrastructure works. I just wanted to point out that it's there. And then I'd also like you to read this page or two on what's different between the internet and the World Wide Web. So the internet is, who owns like the cables that the internet runs on? Anybody know? Well, this is what we call the internet infrastructure. So obviously there's wires and stuff all around the world, right? That is the internet. Who owns those cables and wires and undersea cables and satellites and all of that? Any guesses? Who does? Yeah. John, what did you say? Phone companies. Yeah, this is the phone company. So, I mean, it was back in the 60s that the government, we were in the space race, and DARPA was established to allow the U.S. to compete in all kinds of technologies with mostly Russia at that point. And one of those competitions was the race to the moon. And the other competition was the race to the internet. That's how the internet came about at that time. And so the government kind of twisted the arm of all the telephone companies saying, we want to do this special kind of data network, and you've already laid all these cables around, can we use your cables? And so really it's AT&T, it's all these big internet or telephone companies that provide us with the connections to our houses. Now those don't always run all the way to our houses, because you might say, well, I get my internet from Comcast. Well, Comcast is a telecom company. They've traditionally been a TV company, but somewhere or another Comcast is connecting into major telecommunications connections that are provided by AT&T, and it's all kind of a collaborative effort. That's the internet. And the internet can send any kind of packets of information. All right? And the web is just one type of service that runs on the internet. email is another service. There's all different kinds of services now. But that's the difference between the web and the internet. Technically speaking, if you say that you're on the internet, you're not really saying you're on the web. They're not interchangeable. But for the most of us, we say them interchangeably because the web is such a huge part of what the internet does nowadays. All right. So read a little bit about that. I gave you the overview of it. Mostly I want to get into this. This is my presentation about how the web works. And it picks up very nicely from what we talked about last week. Last week I showed you how you create this website, and this website is a collection of HTML files, image files, CSS files, and all of these are kind of interrelated. And typically, they're stored in one folder on your computer, so they're organized in one location. They're not spread out all over the place. Not typically, they need to be. It's almost a rule. And all of these individual files within this folder refer to one another by their relative position. So in this case, actually, if index.html wants to refer to seal.gif, all it has to say is open seal.gif, and the browser will say, well, since you didn't specify a location, it must be in the same location where you are. So it'll look in the same folder that index is in and look for seal. And then it's the web browser's job to pull together all these different files and read the instructions in the HTML and the CSS to determine how to lay them out on the page. That's why it's called a markup language, hypertext markup language. That's HTML. It marks up where things are supposed to be on the page and how they're supposed to look. So in this case, here's an HTML file. You have an image reference that's seal.gif, another file referenced, profile.html, and a style sheet reference, style.css. And because we just say the names of the file, the web browser will expect them to be in the same location as index.html. Here's something hissing? Yeah. I hope it's not a gas leak. A more complicated site might look like this. Actually, this is still a fairly small site, but oftentimes we get a lot of files within a particular folder, so we try to organize them into subfolders. So in this case, we actually have two HTML files here that are in the My Site folder, but it turns out we have several images, and so I've created an images folder to hold those images, and it turns out we have a couple different style sheets, so I put those in a styles folder. And this is fairly typical. I would say the vast majority of websites out there store all the images in the website in a folder called images. I think we ask you to do that on these first assignments as well. It's really easy to see why this is the case, because otherwise you'd have so many files it would be impossible to find anything. In a website this size, it's not a problem, but this is small for a website. So in this case, if I go back a couple files, if I stored seal.gif in an images folder, what I would have to put here is images/seal.gif, so that the browser would know I have to go in the images folder to find this file called seal.gif. There's another way you can do it, however. If we then move this website, let's say we move this entire website over to iSpace, all of these files now have a location on the web, right? They're at ispace.ci.fsu.edu/username/images/logo.gif. You can actually refer to any of these files with its full URL, the http:// and the whole name. And we can do that. Over here in this file, instead of putting seal.gif, we could put a whole web address there. All right, well, now we'd have to make sure that that file always is at that location on the web, but that would work fine. And there's a difference to how these work. These, when we do it this way, we're saying seal is in the same folder as index. So we've just given you the name. That's called a relative reference because we're telling where this file is relative to where the current file is. All right. The other type of reference, when we give it the full URL to the image, is called an absolute reference. That's what this is saying right here. So when we do a link to www.fsu.edu, we're doing a link to an absolute reference. That's where its location is on the web. All right, getting more complex, and we're slowly working our way around to your question about programs. Websites are copied from your PC over to the web server using FTP software. You guys getting comfortable with that, except for being unable to log on? Most of you guys able to log on and see what's there? Good. I'm concerned about this because this is one of the big steps, is getting this transfer over from your computer onto the web. And it's not without errors. If you're able to do it the first time without any problems, you're a genius. All right, so we can click and drag it from our file system over to the server file system. So when a person sits at a web browser and types in ispace.fsu.edu/username blah blah blah, what happens is when you hit enter is the web browser then sends that off to your internet connection. And there's the domain name service that runs on the internet that essentially looks up the address you typed in your menu, in your address bar, and you're quick, and it automatically translates it to an IP address in a location on a server somewhere. The domain name system, the DNS servers, they're really important. In fact, they're a primary target for hackers, because if hackers can take down the domain name service, the whole web would crumble. And one of the scariest attacks has to do with hackers going into the domain name service and changing the location of web pages. So if you can imagine bankofamerica.com, you type that into your browser, you're feeling pretty confident that the web page that opens is on the Bank of America's server, right? Now, there is a hack that allows them to have that address go to their own server where they've copied the Bank of America's website, and it looks just like it, and you go in and you type in your username and password, and they've got it then. Then they can take that and go to the real Bank of America's server. It's happened once, enough to scare the bejesus out of everybody. Excuse me. And they've locked down. They've corrected. There were some security holes. Every once in a while, you'll hear these news stories about. Excuse me. Got that move around this lump in my throat. About security holes that were discovered on the main domain name service. And so they keep it locked down. But if that were to happen, the whole integrity of the web would crumble if they were able to hack that. All right, and we talked about this idea that you put things in your HTML folder. And so the web client software requests pages from the server, and the server serves them up. For us, people put tilde username, your username, and that automatically tells the server to look up your user account and then show whatever's in the HTML folder there. Yep.
I know you have to pay for a domain name, but what about if you want to host your own server? Do you have to pay your phone company or anything?
No, you can do that. I know several people who do that. You just have to direct your domain name over to your IP address of your computer. So your computer would have to have a static IP address, that you can map the domain name to. And Comcast generally swaps out these IP addresses assigned to different computers just for security purposes. So you might have to request a static domain.
So isn't that a way so you can have a free website?
Yeah, it is. It is, but you'll find that it's not easy to administer your own web server. I mean, it's easy to put it there, but it has to be up all the time, and also you have to be able to manage the amount of traffic that's going to come over your network, your home network. That's the biggest deal. My son is into. I have a 15-year-old who's into Minecraft. You all familiar with Minecraft? And we went through a whole deal where he set up a Minecraft server on his PC in his bedroom. And I'm saying, I'm not feeling good about this. How many people are going to be coming onto your server? And you have to put, special permissions into your router that allow certain ports open access to your computer. And so typically, you're able to put stuff out there, but people can't come into your server. When you open it up to the world to become a server for Minecraft or a website or whatever, you're allowing people to come into your home network. So there's a security risk there. You have to keep your site up all the time, and you have to be able to manage the traffic. All of a sudden, you're not going to be able to get on the web because all these people are accessing your website. So his solution, he just did, he's thrilled about it, is he found a virtual server hosting company that gives you tons of memory, and it's your own dedicated virtual server, and it was like $15 a month, which is real cheap for the amount of traffic this server can handle. So, and I feel much better about the situation now. Send all your friends over there to their server and see what happens. But yeah, you could host your own website, no problem. So what happens kind of as we look at this is, the primary domain name is everything that comes after the HTTP up until the first slash. So ispace.ci.fsu.edu is the domain. The top level domain is .edu, so that's classified as an educational server owned by an educational institution. After that, the next part, tilde username, tells the web server where to go within its storage to access this website. And then the part after that tells it where within that account to look for the file. Okay? And then the web server delivers all the files that are part of that page. So, sometimes if there's a video within a page that's not just embedded YouTube, but actually a video, it might take forever for that page to load. Or if that page has a whole bunch of photographs, it's native resolution, like 8,000 by 8,000 pixels, that page is going to load very slowly. So as web designers, we have to consider how fast pages load to keep our images down to a nice small size and keep their number down for fast loading. Because all that stuff, all the files within that page are loaded into the user's cache then, or memory, and served up. So the important points from this is that web pages and sites are made up of these interconnected files. Website files must maintain their location relative to one another within this web folder. Websites are typically developed on a PC and opened in the browser, previewed in the browser, reading it right off your PC, and then transferred over to the web server. Web client software requests web pages from web servers using a URL. Web server software and the domain name system translate URLs to physical storage locations. And then I talk about the iSpace location of where your stuff is.
For the second point on that, does that mean that the order matters, or?
No, not the order. Not the order, because you can list things in order of anything, file name or size or date or whatever. Order doesn't matter, just the location, in the file hierarchy, I guess the order matters, just so that they stay in the same folders relative to one another. That's important, and I wonder how far to go preaching on it, because I talk about it all the time, and I think until you get into it and make mistakes and learn from those, that it's hard to really know if you get it or not. All right, so there's a couple different ways to put programs and interactivity in your websites. One of the most frustrating parts of this class is that you won't learn the skills to to create an interactive website. People won't be able to become a member of your social network and post comments and things like that. We actually do that in the next course in this sequence, CGS 2835. The final project in there is actually creating your own social network. But you can't do that unless you learn to program. And doing HTML and CSS isn't programming. Programs use logic and accept user input, apply some logic to it, and produce some types of results. HTML doesn't do that. It's a markup language. It's not a programming language. But there's two different ways that you can implement code within a website. And we refer to them as client-side programming and server-side programming. With client-side programming, the code is actually embedded right in the HTML, and it runs on the client's computer, the user's computer. With server-side programming, the page you're looking at sends input to the server, where on the server it's used as input, and the server generates output and sends a new web page to the browser. By far, the most popular programming language for client-side is JavaScript. And at the end of the semester, I will give you a little JavaScript code you can put into your page for a little interactivity or a little animated effects. But we're not really going to get into it in this class. Not enough time. But this is how it looks. In the head of the document here, I've used the script tag. I've said this is JavaScript. I've set some variables. Variable 1 is called value1, and I give it 45. Value 2, I give it 60. A variable called sum is going to store the sum of these two values. So we have 105. Sum is going to be 105. And a variable string is going to be variable 1, and I write string out to the page. The other way to do this is by using the form tag. I found the hissing. It was the speakers. The form tag collects some data. You use forms all the time. When you log on to Facebook, it's a form. You have a text box there for username and password. Anytime you type things into a form, that's using the form tag. And it's easy to make forms. We'll learn how to do it in this class. But ultimately, you have to give the form an action. You have to send it to a program on the server. Okay? So this is server-side programming. And when the person clicks the submit button at the bottom, it sends the information that the user typed into the form and selected in the form over to the server. The server runs this file called ers.cgi, and that program then spits an HTML page back. It creates the page and sends it back and shows the results. So I have a little demo of this for you. It's not very impressive, but I start with a real simple one so that you guys can kind of see. So you can kind of understand what's going on with this. All right, two programs that do the same thing. One is written in JavaScript, one is written in PHP. Client side, server side. The undergraduate academic progress calculator. Something everybody needs. All right, I've completed, well, let's see. My name is Ken. I've completed 1 credit hour. What's my classification? Ken, you have 1 credit hours. You are classified as a freshman. So what's going on here? Let's view the page source. Okay, down here, this is the body of our web page, right? I've got little CSS going on here, obviously. And here's my form. I have no action associated with it, but I ask for the name, and I put that in a text box. And here's another text box, and this is called name, that's called credits. And then I have a button, submit button. When the person clicks that, on click, we're going to go to this thing called calc. And we're going to send it the value of the name and the value of the credits, this thing called calc. Up at the top of the page, we find this thing called calc. You see up there, function calc, and it's getting the name and the credits. We transform the credits into a number instead of text, and if credits is less than 30, output, you're a freshman. If it's less than 60, you're a sophomore. If it's less than 90, you're a junior, and if it's anything else, you're a senior. And then we create a string. This is HTML, right? We're creating our output here. The person's name, Ken, you have credits, 1 credits hour, and then the comment is what we output here. You're classified as a freshman. We write that out to the screen, and we close it. All right, so that's code. It's JavaScript. It's embedded right inside the page. Yep?
Could you have a different file, like not in the same HTML file, and can it be in a different programming language, like C++?
Not on the client side. On the server side, that's where we're going next. So, and the reason why is that all of your browsers, they already come with the capacity to understand JavaScript. They don't come with the capacity to understand C++. They can understand Java, but not C++. And that's because it's a compiled language. It's an executable that would be created. So let me show you how this works with the server side. The program isn't any more exciting, but what happens is kind of interesting. So this looks like the same thing, right? Except the other one, I'm sure, said JavaScript/JS example. Now I'm Ken. I've created, well, let's do something interesting. 900 hours. What do they call it? I'm a lifelong student. Submit that. Well, the output looks nicer, for one thing. It's easier to apply CSS with server-side stuff. Now, what's interesting about this is when we look at this, view the page source here, there's no code. It's just straight ahead output. All right, so the code is not on this computer, it's on the server. And if I look at the code prior to this page, view this page source, you see we have a form, and the action is calc.php. Now over here, and this is a step I didn't plan to take, but I can't help myself. I want to do this. I'm going to open my command line, and I'm just going to connect to the server. This is another way to connect to a server. There's lots of different ways. Oops. FSU made me change my password recently. I'm getting used to it. All right, I'm on iSpace now. Take my word for it. And we look at the URL. We know this is in my kbaldoff, my home directory. And so we must know it's in, and I'll make this a little bit bigger so you can see what I'm doing. So I'm going to CD over to HTML. So now I'm looking at HTML. I don't like the black background, but I can't do anything about it. Now, in HTML, I need to go to a place called WebDev. I'll go to WebDev. In WebDev, I need to go to a place called PHP. It's all in the URL. You know, this is on the server. We're just reading where it is from the URL. And then I need to go into JS example. JS example. And then I need to look for a file called calc.php, because that's the action. This web form is sending information to calc.php. And I can look at that file on the server like this. So there is the file. Remember, we're getting the name and the amount of credit hours, and then we're spitting out some output. Let's just maximize this.
I mean, nobody else would be able to see that if they're just
Nobody can see this They don't have access to the server in my account, exactly. So this is where I'm saying you can hide your code if your web page does something. People can't see how you do it. But as far as the outputs you create, you can't hide that. So this is calc.php. I connect to a style sheet, and I do the same thing as I did before. I get the name and I get the credits from the form, and then I do that output. And instead of saying line out, we do echo string. We just output it, and it sends the output over to the browser. All right, so like I say, this is beyond the scope of our course, but I think it's useful to understand how this stuff works, what's happening, and understanding the difference between server-side and client-side programming is a valuable tool. So let's get back to our presentation here, because I'm just about done with it. So the HTML forms, the form tag is used to collect user data and send it to the server for processing. And sometimes you can send it so you can see what the person sends. So when we go to index.html, you've probably seen this in URLs before. Question mark name equals Ken. It's actually sending that information you typed into the form to the server. Sometimes it's useful to be able to see that in the URL. And PHP has become quite a popular programming language for the server. It's one of the easiest languages to learn. That's what we teach in the next class. Sometimes besides PHP, there might also be a database that's on the server. So when I go to Amazon.com and it shows me all the stuff that I might like to buy, it's reading my information from a database. So the PHP is perfect for sending requests to a database, pulling that stuff from the database, creating the web page, and sending it back to the user.
Ken,
Yeah.
remind me again what the PHP stands for.
Pretty. It's a really weird thing. Exactly. Thank you. Great minds think alike. We still don't know. Where is it? Oh, this is where I learned what it is. Some time ago. Did you see it somewhere?
Yeah, it said it originally said the personal homepage down.
Really?
Yeah, but I guess
It's called Hypertext.
it's right next to it.
Yeah.
History.
Yes, pre-processing hypertext or something.
It's
the last sentence of the
Okay.
It should start with an H, but it doesn't. It stands for
Here, hypertext. Oh, PHP hypertext preprocessor. That's what it is. And this is something programmers love called recursion. It's when you refer to yourself within code and it gets deeper and deeper. So PHP stands for PHP, stands for PHP. You know, PHP is part of the meaning of what it stands for. So it's just one of those nerdy things that makes us all scratch our head and say, why? All right, so I think I'm getting to the wrap up here. So on the client, your Internet Explorer, your web client software is able to read HTML. It's able to give you a form to accept user input. It's able to show images, understand CSS, JavaScript, and Java. And then on the server side, you have server-side programs that run in other PHP and other programming languages, and also databases like MySQL and other database manipulation languages. So that's kind of how it works, and hopefully that makes sense to you. I did also prepare, and we have a little bit of time. Any questions, though, before I go on? I refreshed my memory on the interface design chapter, and it's a pretty quick one to go through. I just wanted to bring out the high points of this chapter.
For more information about FSU's program in interdisciplinary computing, visit www.pic.fsu.edu.